Welcome back to another episode of the Braun Performance and Rehab Podcast, powered by ISOFIT and Firefly Recovery. ISOFIT is my go-to for all things isometric strength training. For more on ISO, be sure to check out ISO. Episodes like this are made possible by Firefly, the official recovery provider of the Braun Performance and Rehab Podcast. For more on Firefly, be sure to check out recoveryfirefly.com. This episode is powered by Dr. Ray Gorman, founder of Engage Movement. Learn how to boost your income without relying on sessions. Get a free training on the blended practice model by following at Ray Gorman DPT on Instagram. Athan, welcome to the podcast. I'm super excited to work with you today, man. For people who aren't familiar with you and the company you have, Kinvent Biomechanics, would you mind filling in a little bit about who you are and all the amazing stuff you're doing in the space, man?
Hello there, and thanks for having me. Actually, yes, I'm the founder and CEO of Kinvent. Kinvent is now 8 years old, and Kinvent helps sports and rehab professionals assess progress while building patient engagement and athletes' performance. So what we do is we have developed an app to which we will connect different sensors to assess and train strength, balance, and motion in both physical therapy, coaching, athletic training, strength conditioning.
Absolutely. That makes a lot of sense. And as you mentioned, strength, balance, motion, there's a lot of different things that go into this human movement, human performance kind of puzzle that way. And ultimately, I think a lot of it comes back to your understanding of biomechanics, how the body works, how the body moves, different things like forces, force vectors, levers, and so on that way. So when it comes to this concept of biomechanics, before we even get into the amazing sports science side of this that way, what kind of things do you feel like clinicians and coaches need to have a firm understanding of just from an overall biomechanical principle standpoint before they start talking about applying things like dynamometers and force plates and so on that way?
So that is a very interesting question and very broad one. Biomechanics is a great science. Actually, biomechanics is not just one science itself. It uses tools from other sectors like mechanics. Okay. Like anatomy, like kinematics. So actually, all those areas, and of course, because we talk about technology and biomechanics, let's not forget electronics. Let's not forget software development. Let's not forget radio communications. All this kind of stuff, sensors, okay, signals that we have to treat. All this kind of stuff that we need to actually build a sensor, a system that will detect a human movement, a force applied to something that's moving, something that is contracting, signals that will have to convert to something that easily an athlete or a patient will understand, okay, that it will give sense and will help the practitioner decide the right thing, and then that this same patient or athlete will use to train. So biomechanics can give you that, okay? But the very important thing is to understand what's behind the numbers. Because, if Kinvent or any other company gives you a number in Newton or a number in degrees, okay, or in speed, or acceleration, well, you have to understand what the test was, okay? And you have to understand how this is moving over time and that you measure it the right way. Because numbers sometimes can be tricky. And if you don't do the right test and you get the number out of the test, you may end up with a bad decision. So generally, you need to understand what this number means and how this number was provided through a test.
Absolutely. You have to have that in-depth understanding of the science behind it. And as you were kind of alluding to, one of the big things is just understanding kinematics versus kinetics that way. Are we looking on, the understanding of the causes of motion, things like force or torque that might act on the object? So that'd be more all on your kinetic side of things. Or are we looking at different things that describe an object's motion, right? Like velocity, right? Like one of the things that you have, I believe it's called the power. Don't quote me on that, but the power that allows you to measure like velocity of movement when you're doing different exercises, right? So to me, that kind of falls under that kinematic side a little bit more. But, if you're someone who's like, I don't even know what kinetics is, it's one of those things like having a little bit of the base understanding of some of that stuff that, back in the day, Physics 101, we kind of gloss over. It's like, man, am I ever going to use this? Like, As someone who's on the other side of it now, you definitely do use the physics 101, 102 stuff. And if you have a firm, solid understanding of some of those physics principles, I feel like you can really apply it a lot better when it comes to your sports science practice and when it comes to just your overall understanding and application of movement-based principles, right? Like you were saying about different things with numbers that way. I mean, just thinking about the difference in someone's jump strategy that might come from the fact that they might achieve maybe 40 degrees of closed chain dorsiflexion in one jump and 20 degrees in the next jump, right? Just a little difference as far as how far they can dorsiflex in that closed chain position will be the difference between a more knee dominant strategy and hip dominant strategy. And I'm not saying knee exclusive or hip exclusive. I'm saying dominant, meaning if we get that knee further over the toe, I think everyone will agree we're going to get a little bit more quad activation than if the knee is kind of hanging behind the toe. So understanding these basic principles, in my mind, really set the foundation for all of the fancy cool stuff that you all have, from the force plates to, dynamometry, power output, and so on that way.
Yes, so just to explain to everyone the difference between kinematics and kinetics, to start with the basics, kinematics actually is the description of a movement itself. Okay, like my body is moving, it moves in a certain speed. This is kinematics. It rotates. That's also kinematics. I have a certain angle on my shoulder. That's also kinematics. Okay, but then kinetics describes the why behind that movement. Okay, the root cause. For example, my muscle contracted, it generated the power, a force on the ground, and this actually gave me an acceleration. This is kinetics. Okay, kinetics is force equals mass times acceleration. Okay, kinematics is acceleration equals difference of speed over time. This is kinematics, and this before is kinetics. So in biomechanics, we need both. Okay, actually, kinematics is what makes someone, describes who will win the race. Who is going to win the race of 100 meters? The guy that has the biggest average speed. The guy that will do, or the girl, the smallest time. Okay, 9.52. But then kinetics will help us understand why he was able to win the race. Why was Usain Bolt so fast in his first? Why was he able to get the biggest speed, the biggest max speed of everyone else in the race? Why was Usain Bolt the slowest one to get to that max speed compared to everyone else? Okay, so this is why we need to understand that, because afterwards we are able to work on that. Okay, because if you can measure it, you can improve it, and to measure it, you need to measure the kinematics and the kinetics on the same time. Does it make sense?
Absolutely. You need the data to talk to one another. You need the data to overlap, and you need to be able to get all of it in a detailed, accurate fashion. And on top of that, you have to understand that all of these things, it's not just one thing. And that probably wasn't the best wording, but plates, power output, and so on that way. It's never just one of them telling you the whole story. It's all coming together. It's all of the pieces creating the entire puzzle that way. But it's not as simple as just throw someone on a traditional set of force plates and get everything you need, because a lot of times with force plates, it gives you one, maybe two axes. And I think that there's another axis that enters the picture as well, right? Everyone always talks about the x-axis and the y-axis, but where does the z-axis come into things?
It's the opposite, actually, as everyone talks about the z-axis and they do counter movement jumps. And let's work on the rest. But you're right. Actually, you are so right that let's think of the human body first. Okay, let's take a step back. The human body is so complicated that if someone thinks that they can describe it perfectly, this is impossible. It is impossible. It's a chaotic system. Chaotic, that being said, it has some rules. And thanks to those rules, we are able to measure stuff and then get decisions done. So we are able to measure a ground reaction force, and force plates. We are able to measure speed. We are able to measure acceleration, muscle contraction, range of motion. We are able to do those in an analytical way. Let's say, for example, we ask from a person to move their shoulder only. This is an analytical test. But it's even more powerful if we are able to describe those movements in ecological conditions. I mean, why does a basketball player like Steve Curry, how is he able every time to jump and shoot by himself? There's no one in front of him. Why? Because his lateral skater jump is so fast and he goes so far that whenever he does it, there is no one able to follow up with him. Okay. Why is Usain Bolt? Why was Usain Bolt so fast? Why was he able to accelerate that big when he was on his 100-meter sprint? But it's because actually he had a very good. He had long legs. He had a quadriceps that was very, very well made. Okay, with an ability to generate not only isometric force but mainly power. Okay, so he was able to generate power also in the latest in the latest part of the 100 meters. So even when he was at his max speed, he was still able to generate power. Okay, so he was able to maintain that speed and to be the fastest man alive. So all those things we have to be able to measure them, and we have to be able to measure them on all three axes. Because the human movement doesn't just move up and down. Okay, it moves around. We pivot, we run, we do miles of horizontal movements and only inches of vertical. And that's why, for example, force plates, we made 3-axis force plates. We made 3-axis force plates because you do a change of direction, because you are going to jump forward, because you are going to go sideways. Okay, you're not just going to do a counter movement jump. I've never seen anyone getting injured doing a counter movement jump. It's not a thing that you do when you play a game, right? That is the why behind the 3-axis. And that is the why also behind the K-power, because K-power is the sensor that will measure both distance, speed, acceleration in all axes. Okay, because we run, because we move things, we lift things, right? So those things, we have to be able to measure them ecologically, so close to what's happening on the field. Okay, and to do that, all 3 axes count.
Right, absolutely. Having that z-axis in place allows you to refer to basically like a rotational axis, or now having a rotational center line, as opposed to just looking at things forward and back and up and down, right? It adds that new element to it that, as you mentioned, carries over better, in my opinion, to the understanding of sport performance, sports rehab. But I would also add in a lot of the injury components as well, right? I feel like we've kind of looked at this injury epidemic for a long time, and we've been saying, what are we missing? What are we missing? But if we're not even assessing all of these variables within the 3 different components, the 3 different axes of a simple Cartesian coordinate system, then, you know, what is our data telling us when we've literally missed the whole axes of motion in the process that way?
You're right, and injuries is a big thing. At injuries, I mean, I don't know if you saw the statistics, but well, you know that ACL injuries have doubled in the last 10 years in competitive sports, and you could say, well, I mean, what do we do wrong, or what shouldn't we be doing? And it's pretty simple. Performance is higher and higher. And because performance is higher, the games are more and more demanding. And they are more and more demanding. And you know what? Athletes, they prepare themselves better than 10 years ago. Better. It's true. I mean, there's so much science done in the last 10, 20 years in sports that athletes really train better. But, I mean, they train better, so they get more powerful, so they get they get stronger. Shocks, for example, in football are bigger, right? They run faster, and so they change direction faster. And you know, the human body, it's a human body. It has a certain number of joints that are made in a certain way for the past million years. So this can't change. But we are demanding more and more of that. Okay. So this is why actually more and more injuries, even if we get prepared better. So we need to understand the whole mechanics of that thing and not just do it in one direction, because one direction it's a good starting point, but it's all we had. That's why we did it. It's all we had to measure. Now we can do much more. And let's try to understand. Let's try to understand when you change direction if your technique is good, right? If, for example, your technique build creates lateral torque on your knee. This can be really painful on your ACL. And there you go. If you can work on that technique because you understood where the problem is, you can show that to your athlete, and the athlete will understand and they will correct. And if they correct that, then the smaller the risk, then the smaller the rate of injuries.
Absolutely. And now you're not only able to correct it and intervene with it, but you're also able to, as you've mentioned, assess it and, in my opinion, evolve what we've been doing for the past several decades, right? Like I look at a lot of different ACL return to sport criterion tests and assessments and that sort of things. And I'll be honest, a lot of the protocols I get clinically, they're the same as they were 30, 40 years ago. There's not a whole lot changing. And a lot of it is still straight line sagittal plane assessments when, as you mentioned, the ACL in particular in this case has a role in rotational stability of the knee. It has a role in multi-plane stability, not just translation forward and back, but also a rotational component. So if we're not assessing different multi-plane type activities, like you mentioned the skater hop on the force plates before, it's one of those things that, like, to me, it just makes sense. It's like, hey, the ACL is often injured with lateral type movements where there's frontal plane or rotational forces at the knee. How are we going to determine if someone is ready to go back to sport if we've never done or assessed anything in that plane of motion? It just intuitively does not make sense. So I think we as a profession, we as a society, we as healthcare need to look at it and say, this is probably one of the many missing pieces that we've had over the past several years. And we now need to build in different tools like a 3D style assessment that allow us to get a little bit more specific with some of these different things, like the skater type of assessment that way, that gets us more specific in the multi-plane demands of sport instead of just more forward and back, up and down.
Yes, philosophically speaking, to be honest, you know what? Humanity does with what they have in their tool belts. Okay, so if you only have a hammer, all problems seem to you like nails. Let's try to build more tools than hammers. Okay, the screwdrivers, the electric ones, whatever. And that's the philosophy behind those kinds of tools in biomechanics. I mean, before force plates, there were jump ones. Okay, you had the time. And then you had vertical force plates. So what did people do? They tried to find a correlation between what they had, that they could measure, and what they observed on the field, saying that, you know what, if there is a big asymmetry on your deceleration RFD between left and right, chances are bigger. And that actually, it's human observation. Okay, that's how science was born in the first place. But then between the observation and what you can measure, there's a black box. Human body there are still areas that are black boxes, but you need to be able to describe it as better as you can. And that's the idea behind, even again, 3-axis motion analysis. It is important. Okay, I can't say that we invented it. It's not true. It was here much before, long before we arrived. But it wasn't available for every practitioner. Okay, you had to go to the lab. The option was that you had to go to the lab, the big expensive lab with the PhDs, with the expensive equipment, the one where you need hours of setup and weeks to get the results. And once you get the results, you, the practitioner, only the PhDs that wrote it understand it. So what did you do, you practitioner? You went with a hammer. You took your phone. You filmed. You got the vertical force plates that you had. But we humans, we move around. We don't just move up and down. Hence, the idea of trying to describe better this black box.
Absolutely. Absolutely. In addition to the skater, what are some of the other different assessments that you use with the tech that you have that allow you to kind of get into these other axes and other planes of motion that are often not commonly assessed in traditional rehab settings?
Yes, so thanks for this question. So we talked about the skater jump. So you jump laterally from one leg to the other, easy. But let's try to be as close to the field as possible. And it depends actually on the kind of sports. So change of direction, rugby, football, basketball. Change of direction is crucial. And so the change of direction 90 degrees and 45 degrees is really, really important to be able to understand this last step the one where your whole body arrives with the speed of, let's say, 10, 15, 20 kilometers an hour, or like 15 miles an hour, and it comes to the x-axis, and you have to transform this to the y-axis pretty fast in just 300 milliseconds, okay? Where everything has to be aligned perfectly, otherwise you put things at risk. And on the same time, you have external factors like another player coming in, okay? And also all this kind of non-compensated, non-anticipated movement that you have to do, okay? The chaos of real life sports. So change of direction is crucial, and you have to do it not only with what you can measure on the ground, but together with the video, because an athlete understands video. They understand when they see themselves. They don't understand sometimes force vectors, but they understand the video. And if you show them where your force vector is and how you should place your knee when you do it, this they will understand because they want to be better of themselves. Okay, so let's change of direction. Then let's go also in basketball, volleyball, 1-2 jump. Okay, and this is about performance. You want from volleyball players to jump as high as they can when they want to smash the ball, right? They have to be on top of their opponent. Same for basketball players when they shoot. How can you measure that? You could, for example, measure flight time. That's easy. You could have done this like 30, 40 years earlier. That's easy. But then, do you know if they convert really their horizontal speed to vertical? You don't. So you have to be able to measure that. Hence, they want to vertical jump on 3-axis force plates, because this one, you can train your guy and you can tell him, listen, in your final jump, you arrived with 2.4 meters per second. You were able to transform this at 70% into vertical one. You know what? Arrive with 2.7 and get the 70% to 80%. You will gain 2 to 3 centimeters, 1 inch with 1 inch. You are on top of the opponent. You get the point. You see what I mean?
Absolutely.
So and then it's about landing and change of direction. So let's say that I play rugby. I have to jump, catch the ball, and as soon as I land, get away from an opponent. Okay, like non-anticipated stuff. And this is where injuries happen. Okay, so this is something you have to be able to measure. You can do it with 3D deltas. That's an example. Okay, and then it's everything that happens on one leg. Okay, so unipodal, change of direction, unipodal forward jumping. Okay, and those are movements where injuries happen. And then when you get back to performance, we have an example, the broad jump. Okay, in the NFL, that's a draft test. This test decides if a player is going to play the NFL or not. That's crazy, right? It's very important. It's actually the ability of players to be explosive on the forward plane. Okay, and we measure that with a tape. It takes its time. It has its own precision. With 3-axis force plates, you are able to measure that in 2 seconds. Okay, and so that gives you the performance, that gives you asymmetries in impulse. Okay, that gives you actually the explosiveness of the person on the forward plate. So you have everything that matters.
Right. So when you say in particular with the broad jump and the 3D force plate, you're saying start on the plate and you're jumping off, and then you're getting all of the metrics into the ground when they push off for the broad jump, correct?
Exactly. So in this particular case, if you only have one pair of force plates, you get the takeoff. But the takeoff is what matters in that test, right? What you want from the player is to be explosive from starting to acceleration, because you want them, as soon as they get the ball, to flee as fast as they can, right?
Absolutely.
So this is why you want that. And this is the most important part. Of course, landing would be important for injury prevention, that's for sure. But first, let's start with the takeoff, because this is what defines performance. Does it make sense?
Absolutely. It makes a ton of sense. And it's also the kind of thing, like you mentioned the counter movement jump before. With the broad jump, there's almost always a counter movement in effect, right? So you're getting to assess efficiency of the stretch shortening cycle here. Right, like you could very easily take counter movement jump and squat jump and just translate it into a broad jump assessment, right? Use a counter movement, don't use a counter movement, note the differences, right? How effective are they at using the stretch shortening cycle between the two? And then on top of that, if there is something that's going to show up from an asymmetry standpoint in the rehab process, and this is just my opinion, I don't have any specific citation or data for it. However, from what I've seen, the most common issue is in that initial phase right before propulsion. When we're coming down from the counter movement into that eccentric, that's where I'll see a lot of people start to shift. Right before they push off, that's where I think you'll see a lot of stuff come out. And again, as you mentioned, assessing the landing is important as well. However, I see so much happen in the initial, like, first two phases, that braking component and then the propulsive component of that kind of counter movement motion, if you will.
I see. And you're right. In the eccentric phase, we will see lots of interesting stuff happening. Okay. And we'll see them even more if we look on three planes, because you can do it on a counter movement jump. But when you do it in the forward on the lateral, you see even more, because you know what? The human body wants to protect itself. So it wants to protect itself, and it will protect it more if conditions are harsh. So just the vertical part, it's easy because you know what you're going to do. It's just on one axis. You'll find a way. But when it's in three axes, the protection reflex is even bigger. So it is very, very important to be able to have those. And that's why in the forward jump, for example, you could have a 20% asymmetry on your deceleration RFD on your counter movement, and then have 35% on the forward, because it's much more complicated. And so unconsciously, your body takes the lead. And there is a second thing. It's about performance. Let's imagine you train people to be better jumpers. Okay, so you will assess them on their vertical jump, and you train them on squats. Are you sure they convert this into forward? You're not really sure about that. Do they have the right angle? Do they have the right technique? Do they really push the same, left or right? You don't know, right? So if you want to train someone to be a better broad jumper, measure the broad jump, right? And measure its kinematics as well, because this is what will show you. This will show you what you need to work on.
It almost makes like too much sense, and it's crazy to think that for the longest time we've went at it in a way that, you know, we look at all these tests and assessments, we're only looking at how far they go. We don't look at how they get there, right? Even with, you know, as you mentioned, even with jump height, we've measured ground contact time. We've measured takeoff velocity. We've measured, you know, RSI and different things like that in the past. Like it's not you don't need anything too fancy to assess RSI. We've had that, but there's so many other pieces to the puzzle, as you've mentioned. And I mean, obviously, we've talked in relation to a three-dimensional force plate assessment, but I'd take it a step further and say you've got to pair that with some of the other data that you can get, right? You got to pair that with your dynamometry assessments as far as force output of specific muscular groups and specific motions, right? Are they stronger on one side than another? If so, what does that look like? What are those ratios and imbalances like? And then I would say you can also throw another layer on top of it. This one I'd say is a little bit more optional, but you could use something like a surface EMG, and now you can get data on muscular distribution rates. You can get understanding of imbalance in actual activation levels from an electrical impulse standpoint, and pair that with your force output data. You might find that, hey, you know, on one side, force output is high and activation of a tissue is low. And that might not be a great thing, because you're like, well, where is that force coming from? Maybe it's coming from a different muscular group. But by the same token, it might actually be a great thing. It might be, hey, you know, we're EMGing, assessing, you know, all four muscles of the quads, and their activation level is low, but the force output and knee extension is really high and really good. Maybe this person is just extremely well trained and they're really efficient in their movement strategy of using the quadricep muscle. As you mentioned early on, it's not just one piece. It's all of the pieces of the puzzle coming together, and it's all of the data talking with each other and communicating with one another to create the entire story and the entire picture here. And I think, just like you mentioned with some of these different assessments that we've overlooked the importance of having all of this data coming together in one place for us to get a really robust biomechanical understanding of the athlete that we're working with, right? One that accounts for both kinetics and kinematic type variables.
That makes sense. You know what? In the beginning of your speech, the thing is, we measured with what we had,
Right.
right? That was the technology until now. Technology available for practitioners. Okay. But we take it a step further. Let's take it a step further. As you said, let's use an EMG on the same time with the force splits. Like, let's try and see what is the muscle that will activate most. Of course, all of it in one single lap, right? Synchronous as it should be. Let's try and see with the K power the speed that the person had in the 5 meters before landing on the first plate, and on this timing before and after. Well, let's try and see what the range of motion was. Okay, and let's also combine all this with a video. So those are things that you can do with Kinvent. Okay, you can do them, and you can do them seamlessly. It's just one click away. And with that, you can really see what's really happening.
Absolutely. Absolutely. You can. And obviously it creates this next, what do I want to say? I don't want to call it a problem per se, but it creates this new obstacle where we have so much data, so much information coming into the picture where now we need a way to process that data that way. And you mentioned early on when we were talking about biomechanics and just laying the foundation for this discussion, the role of technology. And one of the many things I think that's obviously unavoidable at this point is the influx of artificial intelligence into the space and the AI role that it has on data assessment, but also guiding the providers and practitioners as far as what does the data mean? How do I go about creating actions off of this that way? I'm interested to hear your thoughts. Where do you feel like you all are at on the AI incorporation into the process, into the programming that way of data analysis, data assessment, and then actually turning that into a meaningful plan of care, meaningful actions that way?
Right. And thanks for giving me the ball on the AI part, because I believe that artificial intelligence is strong, very strong, as soon as you combine it with human intelligence. By itself, it's dummy, honestly, but together with our brain, it's great. So if you train it the right way with humans, and then humans that use it take what they need, it's a tool, it's a war machine. So what we did is we built our own machine. We called it Cassandra, like the Greek oracle, because she sees everything. And we use it in multiple areas. First of all, Cassandra is trained with our content. Take a webinar, you give it to Cassandra. You have a sports scientist, he talks to Cassandra. Okay. And that's why actually Cassandra can comment reports. Okay. Cassandra can tell you where the jump misses symmetry. Cassandra can give you in a full report of 5 or 6 different assessments, what's the one you need to look at. Okay. Cassandra will also help you build a training program, because we have trained Cassandra with results from assessments and training programs that practitioners would do. And it's still being trained, and it gets better and better. Cassandra will also help you see on a video what the eye cannot see. Cassandra will do a kinematic analysis of that person with just the phone, the camera of your phone. So this is what Cassandra does. It's AI, and AI can be really helpful. You just need to be careful to use it the right way.
Quick break, because if you're a rehab professional sick of burnout, this could be your answer. Engage Movement's blended practice model is a proven system built by Dr. Ray Gorman, a PT who walked away from the 55-hour-a-week grind and built a blended practice model that doubled his income while working less than 25 hours a week, and he didn't have to rely on the traditional way of selling sessions to do so. It's all about blending remote and in-person services, stacking monthly recurring revenue, and building a business that finally supports your life, not the other way around. This model isn't just theory. Real providers, including myself, are creating lives of freedom and flexibility without being tied to their schedule. And as a listener, you get free access to the complete training. DM my name, Dan, to @RayGormanDPT on Instagram and receive your free breakdown on the model. Absolutely. I think that's an essential point, is you always have to take it with a grain of salt, and you always have to understand the context behind it. And I think a lot of people are looking at AI as like a potential replacement. And I think it's anything but. I think it's more of an adjunct. Like we talked about earlier, if you don't understand the metrics, if you don't understand things like rate of force development, if you don't understand how long it takes someone to get to their max force output, if you don't understand the different phases of a jump, whether that be a braking phase, propulsive phase, landing phase, and what that ends up meaning, on your own that way, then don't look for AI to give you all the answers. I think you need to have a foundational understanding of all of these things. And then the AI is kind of the icing on the cake from there in this space. And it is a lot of knowledge and it is a lot of metrics and a lot to look at. But, I don't think that is something that should discount us from doing it. I think if anything, we should look at it like a challenge, right? If a patient or an athlete comes into your clinic and they have a lot to work on, do you tell them, oh, I can't do that, that's too much? Or do you view it like a challenge? Like, oh my gosh, like I can help them with this, I can help them with this, I can do all of this. Like it's something that we should be excited about and should be called to step up to the plate for, as opposed to backing down and backing off because, there's so much data and there's so many numbers. Again, if anything, it's something that I think we should be excited about in this space.
Yes. Artificial intelligence, you have to combine it with something else for it to make sense.
Absolutely. And it doesn't ever replace the coach's eye, correct? Like, even though we have talked extensively about numbers and data and objective assessments, there's still a certain element or certain piece of it that comes from literally just you being present with someone and being able to offer in-person things. And this is more of just kind of like, as you mentioned before, in relation to the hammer and nail, this is an additional tool to help you kind of like zone in on things, right? Now, instead of shooting with a shotgun, you're shooting with a sniper rifle because you're able to be a lot more specific in your approach.
Ah, nice. I like that metaphor. Once again, all the tools that you can use, you have to use them with human intelligence, anything, even if it's AI or sensors or biomechanics, whatever. Because at the end, the practitioner is God. Practitioner knows, the practitioner helps both patients and athletes, and he is going to decide, and he will never be replaced by any machine. Okay, and when you talk about apps that try to build, automatic fitness apps that you're just going to download, there's no adherence there, right? People don't trust the machine. People trust humans.
Absolutely.
So this will never change. And especially in health, this will never, ever change. So if AI comes in, it's because it will help. It will actually increase the pace. It will help get all the data summarized. It will help see something that your naked eye couldn't see. This is why AI is important. This is why the sensors are here as well, right?
Absolutely. No, that makes a ton of sense. And one of the other things that you touched on is that element of just trust that comes with being with someone in person that way. And obviously, as we talked before, just the need for evolution in the space that way. And one other thing I want to bring up is obviously this role of more advanced strength testing, if you will, right? Historically, we did 1 rep max testing because, again, that's what we had access to. That was what the best was at the time. Throw as much weight on the bar as possible, see if you can move it or not. But now there's new ways to assess someone's max force output, right? There's the ability to do isometric testing. And I think the isometric testing space in closed chain environments, not just open chain, but closed chain, right? Your mid-thigh pull, your belt squat, your calf variations that way, hip extension, closed chain isometrics, the ASH testing for the shoulder, and so on that way. Plus the additional element of, instead of just getting the weight on the bar as a 1 rep max, if you will, for a strength or max force output test, you could now potentially add something like a power to it and get a little bit more in-depth understanding of how fast did that bar accelerate? What was the actual distance of the bar from start of the rep to finish of the rep and beyond that way? I think it gives you a new appreciation of, one, the evolution of what you've already been doing, not saying you need to reinvent the wheel, but just adding new things to it. And then 2, the ability to actually get some really in-depth max force assessments now in closed chain positions in manners that, as we talked about before, carry over to sport a little bit better, right? Like I think a mid-thigh pull, a belt squat, some of those things have great carryover to sport and function. And again, you're getting a more true assessment of someone's max force output, right? I've had different female athletes that I've worked with that put out 500-600 pounds of force on a belt squat. But if you back squat them, they're not going above 200 pounds, right? So if I just go by their back squat number, then maybe I'm missing the mark on how much force they're actually able to produce into the ground.
I see your point. That's a good point. And that's why, I mean, the RM is nice, but when you have also speed, you can do lots of very nice stuff.
Tell me a little bit more about what you do when you have those power metrics from a testing standpoint. And also, if you wouldn't mind, I'd love to hear, can you do isometric testing with a 3D delta? Can you do a isometric test, even though it's not moving, that at least starts to pay some respect to the additional access? Because like we talked about before, if it's not in the picture, then you're possibly missing something.
Yes, so isometric tests can give you the F0. I mean, the force that you can put when you power is force times velocity. So if one of the two is 0, then power is 0. Okay, so when you are on isometric, power is 0. Okay, so eventually if you want to work on power, you have to work on some movements, let's say. You have to work on the movement itself. If you want to work on your force, okay, you can do some you can work a lot on isometric testing, isometric training with the ISOFIT machine. That helps. And actually, it's also very, very good for injury prevention, right? I mean, and the risk is so small. But if you want to work a bit on power and have athletes being faster, you have to do also some training on movements that are fast. Fast movements are not with max RM, okay? Fast movements is not with taking a squat at 95% of your max weight. So you have to do it in a way that you will train power. And you can train power, for example, between, let's say, 50 and 70% of your max RM, but following speed. And this is where the K power comes in. So you can just hook up the K power on your barbell and have speed and give a feedback on speed and say, you know what? I want you to be at 90% of your max speed for the next reps. As soon as you are below 90%, just stop. We don't want you to work on a slow movement. If I want you to work on your force, do isometrics. That's fine. But if you want to work on power, work at the right speed. And the K power can help you do that.
Right. And again, you have that objective feedback element, which I know we've talked about it in relation to assessment and feedback for programming and so on that way. But I think the other factor that indirectly, directly, not sure the right way to go about it, influences biomechanics and movement systems and strategies is the mental and psychological components, right? Are the athletes motivated to show up for their sessions? Can you make them more engaging to the athlete, right? Can you give them something that almost adds a like gamification element to it? And, you know, some athletes are not going to respond well to that. Some are just going to want the gritty, grungy, head down, you know, crank the music and just go ham kind of vibe. And that's fine. But there are many athletes now that, you know, grew up in a slightly different kind of upbringing, and they want that kind of feedback that kind of makes it feel a little bit more like a game, as opposed to just kind of like being the one to like jump on the grind train, for lack of a better way to put it. They actually want to find a way to make that process enjoyable. And I think having the ability to kind of add that game element to it can add a whole new dynamic to the actual training and the overall success of the interventions themselves.
Yes, and you know what? We people have changed in the last years. We changed. We want data. That wasn't the case 30 years ago. I mean, not as much as today. I'm going running, I'm always gonna follow my speed, right? 30 years ago, I just went running, and at the end I would have just my time, and that's it. Okay. But we all changed. And we expect from all of the things that surround us to give us this feedback, this metric feedback. Okay. And even the athlete that you described, all athletes want to see if they get better, and they want to see it in every training. And that is important to them to see it in an understandable way in just 1 second view. Okay, so this is also very important. So that's why we build interfaces with a few numbers on it that are understandable, that just athletes and normal people will understand. I mean, you have Grandma Michelle that's gonna go for physical therapy after her hip surgery. Okay, and she needs to know if she's getting better. Okay, if physical therapy sessions bring results. And so she doesn't know Newton's laws, right? She doesn't know how AI works. And we don't want her to need to know that, right? I mean, she could start, but we don't hold her to need to do that. So we have to show things in an easy, understandable way.
Absolutely. I could not agree more. I realize we can probably talk about this all day long until we're blue in the face
Oh.
because this world is just ever expanding and ever evolving. There's so much to unpack here, whether that be the tech side, the movement side, the mechanics side. What are your kind of key takeaways or any other points that you want to discuss that we might have missed in our discussion today so far?
So mainly, you know what, is keep in mind that technology helps, but you have to use it the right way. Metrics help, but be careful. Give the right metrics. Check the right metrics. Also, that too many metrics kill the metrics. Okay, you just lose yourself and people are around you. And that technology has to be streamlined and easy to adapt. And and you have to build buy-in with your customers and your patients. To build buy-in, only facts give you that, and numbers bring facts. So use the numbers, but use them right.
For people who want to find out more about you and Kinvent and all the incredible stuff that you've been doing in this space, where can they find you all at?
So they can, well, there's the website, kinvent.com, KINVENT.com, and then there is LinkedIn. And we actually post a lot on LinkedIn on education, on how to do this and how to do that, how to use the technology, how to adopt it. So take a look on LinkedIn, Kinvent, or on Instagram.
Absolutely. We'll link to all of that in the description below, from the website to the Instagram to the LinkedIn and beyond that way. That way, if you want to find out more, you can just click there and see everything that Athan and his team are up to. And I believe you have a number of different resources online as well that way, different webinars that you've kind of recorded in the past with like expert clinicians and that sort of thing as well, to really help and try and democratize the kind of information in this space, if you will.
Yes, exactly. Go to the website. Everything is there. Everything is documented. There are ebooks, there are webinars, there are things you can read on biomechanics, on how to adopt it in your practice, on how to measure speed, on how to comment, on how to check muscle activation. All of it is there. Justkinvent.com.
Awesome. We'll link to all of that in the description below. That way, if you didn't quite catch it, again, just click there. This was really an amazing discussion. Thank you so much for your time and looking forward to our next chat.
My pleasure. See you soon.